Okay, so hello everyone. Thank you for joining us. We have a very special guest today. Today it's going to be actually really interesting and different than maybe what you're normally used to seeing. We're joined today by Kristen Lese, and I will let her introduce herself and talk about what she does. But just want to thank you for being here. My name is Jaren Dorman. I'm the design community manager here at Gravity Sketch. And essentially what I do is I talk with all of you out in the community. I make some content to help educate all of you on how to use Gravity Sketch and just sort of advocate for everyone out there as to their experience with Gravity Sketch. And yeah, it's just a pleasure to talk to amazing individuals like Kristen today. And so we're very happy to have her. I think it's going to be really, really fascinating, really interesting. I've certainly been fascinated from our conversations that we've had in just our previous calls. So Kristen, if you just want to quickly introduce yourself and tell everybody a little bit about what you do.
Sure. Thanks, first of all, Jaren. It's been great talking. I really enjoy all of our conversations. And also thanks to Gravity Sketch for just, making this happen. And a huge thank you to the Gravity Sketch community out there, especially on Instagram, who I'm not anyone on Instagram. I'm just doing little bits of science to try to understand it for myself. And other people started thinking it was cool. And I didn't know anybody else was out there. So this has been really fun, kind of exploring this whole new world of car design and shoe design and merging these technologies. And it's been so inspirational just for me thinking of like all the things I can do now. But what do I do? That is a good question. So my background is structural geology. So for a long period of time, not as long as the Earth, but for a period of time, I studied the complex structures deep inside the Earth, how the layers go together, how they've changed over time, how they get faulted and folded, mushed together, and how you see that on so many different scales. The scale of a mountain range, down to the scale of how little quartz grains go together. So it's a big field, and that's one of the exciting things that I enjoy about geology. So why did I find Gravity Sketch? I'm a kind of a collector of puzzles. Scientific puzzles are just interesting things, and I ran across this book on snowflakes, and it has my favorite part about, scientific books is when they come with their own puzzles. So in the back, it has this little portion of like the remaining puzzles and mysteries of how snowflakes actually come together. And me as someone who is fascinated by structure and solving puzzles, like this sounds like a structural puzzle waiting to be solved. So I spent a long time just playing around in 2 dimensions, trying to draw water molecules. And as I guess probably car designers and shoe designers know, that when you're working in 2 dimensions, it's so easy to cheat. It's so easy to get to the answer you want because, you can do whatever you want. So I knew I was going to need to like find a 3rd dimension to understand how these structures go together. And so I have a VR set that my husband had put together for me, and I hadn't been using it in a while. So I popped in and like searched for draw, and Gravity Sketch popped up. And gravity is also one of those puzzles that like intrigues me. So the name and the fact that it was free right away, I was like, yes, let's try this. And this was just, let me go back. This was like in January. So I'm just a beginner here. So like, be kind. So I first pop in and I'm like, I just need a sphere with like 2 other spheres, and that's all I need. And I got really overwhelmed and kind of quit at first. It's like, this is way too much for me. But it was, what am I trying to say? It was harder drawing a bunch of water molecules in 2 dimensions, trying to build the perspective and make sure the axes, are lined up, that like I have to go into a 3rd dimension. So I got into Gravity Sketch and just started playing around, not trying to do anything real, but just like, let's go through each of the little buttons. Like, let's just play and explore and have fun. And finally got the inspiration to like build my first water molecule and actually see it in 3 dimensions and think about like, okay, this is where it goes, this is where it goes, this is where it goes. Now I understand. And that just, I don't know, it set loose a whole world of inspiration of what other things I wanted to start thinking about, or like what now don't I understand, or where I need to go look and help broaden my area of expertise. Because at the time, I'm taking a little intro to chemistry class through our library. I'm taking a little math class through our library, like just trying to build up my knowledge. And this is just helping me so much understand how these things go together, that it's a little outside of my area of expertise, but was like really exciting for me. So that, I don't know if that really answered your question. That was a long intro, but
Yeah.
maybe.
No, it's fascinating, and I love just like the fact that it was there, like the name kind of drew you in. Obviously, the aspect of being free, which is, I mean, why we did it. We wanted there to be no barrier to entry. But yeah, it's just really, I think you might be the first that I've encountered in our community that is using Gravity Sketch for sort of not in a field of design per se, but still very much in a field of 3D. I mean, we were talking about this in one of our like our private calls, and how the fact that our whole world is 3D, obviously, you know, and that includes the subatomic, the molecular, the macro, the micro. Everything is 3D. Not just cars and shoes, but just everything we interact with, our whole world. And it was just so fascinating to me and exciting that you are exploring this space, coming from a world of science and trying to work out these puzzles, and convey them to your colleagues and all of that, which we'll get into a little bit, I'm sure. But I want to also say that another portion of this in a little bit, we'll actually jump into VR and we'll take a look at some things that you've been working on and what some of this stuff looks like. So that should be really fun, and that'll be a great aspect of showing collaboration as well as being able to be in VR at the same time. But can you just list off a little bit of some of your prior work experience, like some of the things that you've done in the past, and maybe what you do now, just what your job looks like currently, basically?
Sure. So my degree is in structural geology. So like early on, it was taking a lot of data in multiple dimensions. So you've got point data representing, one little piece of data somewhere else. You have another set of data which might be, depth versus some Z value. You've got cross sections of data running through the Earth this way. You've got surface maps. And so we have lots of different software that you put all of that data together and try to come up with some sort of solution to the puzzle that then you can show to someone else. So that's what I did for a long time, is trying to understand that puzzle more completely, reduce the risk associated with it in terms of like just understanding the shape and size of things, but also the real hazards of like the Earth. The layers below the Earth are not just stagnant and sitting there. They're hot and they're squishy and they move around and they fault, and they generate earthquakes. So what I've kind of progressed into doing is more geomechanical modeling, where you're understanding the pressure regime underneath the Earth and how it changes, and how when you're drilling a well through a different orientation of pressure, it changes the structural picture, let's say, of the pressure regime below the Earth. So
Wow.
that
intense.
was kind of
Yeah.
I know, and I'm doing a lot of this because
Yeah.
these are the things that are so hard to describe
Right,
if you
right.
don't have a 3-dimensional space to draw a fault and show like
Yeah.
things happening.
Yeah, totally. I mean, And one of the things I said to you when we were talking was when you were showing me some of the stuff that you'd made. I was like, man, this would have been. I would have loved to have this when I was like in high school or when I was literally learning like some just the the basic stuff. Obviously not
Hmm.
the advanced stuff like what you do now, but this we were learning basic things like in geology and things
Hmm.
and obviously there's pictures, but I mean, what a way to learn about our world and learn how things work and function molecularly and under the surface of the earth and what a great education tool. And so maybe that's a little bit of a segue we could move into, which is something you've been trying to do at least a little bit with Gravity Sketch, or you're thinking about doing at least. Do you want to talk a little bit about sort of your next steps that you've been doing now that you've been using the tool and how you've been trying to
Sure.
represent these ideas,
Yeah.
essentially?
Talking about school and geology, it's funny. I remember one of my early structural geology classes, my professor was like, do not be embarrassed or whatever. You need to visualize a fault, like grab a piece of paper, bend it in half, like rip it, like have a visual representation. So that's, which is good for 2 dimensions. And that's so much the importance of like if you can get kids to understand a concept the right way, or at least a better understanding the first time, it makes building upon that so much easier.
Yeah.
And being able to see these shapes in 3 dimensions or putting them together yourself.
Mhm.
Because, like, even you're holding, I'm holding a little carbon atom and you're thinking there's a couple places it can go. How do you make that choice? It's like, well, now you got to go figure out, like, um, the solution to that problem.
Right,
So you're
right.
kind of brainstorming and working in 3 dimensions. And so what I had an experience just a couple weeks ago going to a STEM event and getting to see some of the kids and talking to some teachers and showing them what you can do just in terms of Gravity Sketch as a big empty box, and that it's to me like a big brainstorming box that you can go and pull up 30 periodic tables of all of the little details you want to see all at once without having to like flip through multiple screens on your computer or tab through multiple books. But I think building some sort of curriculum that replicates what you see in your textbook, but then you can go home and pop in and actually hold on to these things, or maybe even eventually 3D print them down the road and have some sort of tangible models. But these are some of the ideas. I'm coming up. There are too many ideas to contain at the moment. So
Yeah, yeah. It's exciting though, I'm sure, I mean,
yeah,
just like all the possibilities and um yeah, I understand what you mean in that vein of a lot of ideas, but to me it's exciting. Hopefully, but maybe it's time that we just start looking at some of these things and just let's see
yeah,
what this is all about. So
yeah. That's a lot more fun.
yeah, yeah. Give us a moment. We're gonna switch right over.
Okay.
Okay, so Kristen, we're here in your space. I'm really intrigued. I don't understand at all what I'm looking at, but I'm sure you're going to help give us a little bit of more clarity and maybe educate some of us today. But yeah, where would you like to start?
We'll see. I hope somebody learns something because I'm just a beginner here in the world of Gravity Sketch and whatever, whatever chemistry or physics or molecule building we're doing today. But so come along for the ride. We'll all learn something together, maybe. So the first thing, what I enjoyed Gravity Sketch was just bringing in big images and pictures of notes that I've taken or work that I've done. So what we're looking at here, this is my early struggle of like going through the elements, 1, 2, 3, 4, 5, 6, 7, 8, 9, trying to get a sense of what they look like from the top down, from the side, and then this kind of mixture of angles. And you can see how hard it is in 2D. None of this makes any sense, and I did it. So like, this is where I needed 3 dimensions. So we don't need this anymore. But so what I wanted to do is bring in a bunch of periodic tables and start really understanding what these things look like in real life. And I say that as like a cartoon model. Like obviously this isn't going to be, real, but like just a better sense of of what these things look like. So this is a blank periodic table I brought in just for clarity, and a few of my early draft elements. So like over here, I'm trying to represent these outer electron, I don't know, swarms or fields as like these wispy little, I don't know, clusters of strands that are very easily blown away and like moved around. I see you getting down inside of there because let's see, there's going to be a neon inside of our sodium. Oh my goodness.
Wow, this is amazing.
So this is me just kind of trying to learn. Like I'm just grabbing a molecule, copying, pasting, adding a wing of electrons, building, duplicating. I'm making mistakes. I'm sure some of this is wrong, but I'm kind of learning the patterns and like what's making sense. So what I wanted to do was kind of get to the next level and be like, how do they start going together? And I've got a couple different versions of like, here's kind of my first attempt at carbon with its two little electrons in the p orbitals here. But when I started making like a bunch of carbons, which here, I'll do right there, I was just getting too many objects to really make the type of structures I wanted to make. Like I was dealing with kind of thousands of objects, clustered together. So I realized I need to kind of simplify my design a little bit. This is where I'm going to need some help of designers, or science in general is going to need some help of designers to really understand the most important characteristics of these elements and represent them in a better way. I'm not going to be the one to do it, but if you get enough people in the room getting these puzzles solved, we'll get a better solution, I think. But this is good enough to just learn a little bit about how you can take a carbon, put it together into a little chain to make a nice little ring. Those go together into sheets of graphene. You stack those on top of each other to make graphite. You smush that together to make diamonds. That's coming. I haven't done that yet. I need to simplify my carbons in order to get enough together to make a good diamond.
That is so cool. I just already, that's fascinating to me. Just that problem there that you stated. Working with designers, working with scientists to simplify these bodies and these molecules, so that they can be efficiently represented and multiplied. Is really, really interesting. I think something that people have asked for a lot in our community is a feature called instancing, which is allows you to create one thing and then duplicate it, but all the duplicates are informed by the original version. And so if you make a change to the original version, it changes all the duplicates. And so they're not really, it's much lighter processing wise. It's much lighter load. And so that could be a solution for these types of things where you can have these very complex structures with lots of iterations, but they're more just instanced by a simple thing like just this one molecule like you've created here. Anyway, I think this whole conversation on how we can optimize to better represent these structures is just so cool to me. And anybody out there listening, please feel free, put your ideas in the comments. We'd love to hear it. I would love to see more collaboration in this regard. But
that could be huge, because this is Gravity Sketch is making me think like, as I'm learning how to use the tool better, you can see like this is like a child, I'm sure these little volumes and how I write letters, but it's making me think like, oh, what texture do I want this to be? Like, what is the feel that a hydrogen bond gives you? Like, what what inspires like the type of movement that you think you would see as two things come together. Like
Yeah.
those are real, um, I mean, they're design issues, but I think they have big scientific implications down the road, like
Yeah.
in terms of all sorts of things.
Oh yeah.
So if you want more design problems, let's move on to water, because that's where, so I got to gravity sketch trying to put snowflakes together. And so I'm trying to learn how my elements work to get a water molecule that I understand. So that's kind of maybe the more direct path how I got to gravity sketch. So over here, this is my 2D version of water. It's awful. There's an x-axis, a y-axis, a z-axis. I'm trying to keep track of the orbitals. I shoved a little hydrogen in those two ends. But if you try to deal with more than a handful of those, you're going to get lost very easily. So that's when I tried, this is probably my third or fourth version of trying to make a water molecule. So it's an oxygen up here with its little electron spin orientations labeled. It's got a hydrogen down here and a hydrogen over here with these kind of big positive blobs, which gives water this polar nature. I think of it as magnetic. It's sticky. The positive side wants to stick to the negative side of a neighboring water molecule. Like this is the type of structural, like, what am I trying to say? Simplifying this is where I was trying to go.
Yeah.
To really represent the positive corners here and these negative sides. So that got me to my little cartoon hook and loop, maybe Velcro inspired, unfolded paperclip spaghetti model.
Interesting.
So these are the little hydrogens down here. This is our big oxygen area. So this is kind of representing the little positive nodes of a water molecule, and these little negative areas, which aren't usually represented in images. Let me pull up this next one. So this is me trying to make all the water. Let me start maybe more simply here with these groups of two. Water often comes, or it can come in like all these shapes. Again, I'm no water expert. This is me just Googling water and replicating the shapes that I'm seeing and trying to kind of teach myself how hydrogen bonds work so I can finish my chemistry class through the library and figure out how snowflakes work.
Wow.
So we've got water coming together in two different, so you've got two water molecules being joined by this hydrogen bond. That's how it looks like in the scientific papers. This was me kind of just representing it in the same color so it makes sense. This is just a little cartoon version that made a little more sense to me. Here's another science conundrum. It's like, what color is the positive charge? What color is the negative charge? To me, positive is always red. Just from your experiences in life with electricity, the positive is always red. But if you're in finance or something else, it's negative. So
that is like, actually one thing I remember is positive is usually red. Yeah.
So that's like kind of the first thing I wanted to like swap with these water molecules. Is like I really wanted to see these positive and negative regions of them and how they combine. So you can see water's like so more complex than you really think it is. It's not just little bits of water. It's these chains of water. It's clusters of water. It's tetrahedrals of water. There's these circles of 5 waters, and you've got these like crunched up clusters of 6 water molecules.
So I have a question. So
yeah.
Why does water at the molecular level have all these different structures? What does that actually translate to when you scale it up?
That is a wonderful question. I don't have an answer to that, but I suspect let's move on to ice, and maybe
Sure.
our answers will get
Sure, sure, sure.
solved.
Yes. Please.
Okay, so ice is over here. Let's get rid of our periodic tables and the carbons. Okay, so this is kind of the image I was working off of trying to build ice. And it's a nightmare of a puzzle on its own, just looking at it, trying to figure out like, well, is it that way or is it this way? I still am not quite certain. But what I have figured out is that the easiest way to build ice, they're these little wonky or puckered hexagons. This is a pretty good one. And I can only get to that. I added these little extra chopsticks to really orient the hydrogen bonds so they're in a perfect line. You really want them lined up to make ice.
Wow.
And I think that's what gives ice its a little more structure. Like if you push on the hydrogen bond directly in that orientation, you can push it. But if you push on one, where's one that's like a little off-centered? Like if you push, in that orientation, the bond isn't gonna hold. It just breaks apart too easily.
Right.
At least that's how it works in my mind.
Right.
We'll have to ask the water scientists.
Wow.
So part of this makes me think that like the way that hydrogen bonds might work is that it works better in tension, but when you push water, you get, it breaks apart into its individual forms.
Yeah.
Doesn't hold up the same way it does if you've got chains of these dimers or even like columns of these little, I think they're called trimers. I'm going to need to figure out how to pronounce these things. But you can see how they could probably flow together if the conditions were right.
Would you say that some of these different structures of water are potentially like little micro states that water is in? Like
Absolutely.
Okay.
If we move on to my last little cartoon, which is just made up nonsense.
This is so cool.
I don't know if any of this is right, but I've built like kind of this little fake convection cell, and here's like a little surface. And so I was kind of wondering the exact same thing that you were, was that like you've got all these different types of water. To me as a geologist, I look at this with these 6 oxygens in a position that they don't want to be in. Like they're all scrunched up. They don't want to be that close together. That looks like a bit of compaction or some sort of a compressive event.
Yeah.
So if you've got water moving, circulating, I would think that you'd have different types of structures in different environments where you've got, if you're, again, I'm out of my area of expertise in terms of fluid dynamics, convection, whatever, but you can have these chains of water moving in tension coming up through the center of the cell. You've got tension, what's it doing? Colliding with the air surface, breaking some of those hydrogen bonds, forming different types of structures where you don't have as much hydrostatic pressure above you. You're going to have different types of pressure regimes as you're circulating down. You've got, maybe some of those like more clustery type waters, at depth or in places where water's moving more slowly or has less energy. I don't know. But like, that's what it makes me think.
Yeah, I mean, it makes me so curious, so fascinated.
Right?
And to see it at this level, I think at least for me, it makes me appreciate the complexity of our world and the micro world, and how there's so much more going on that we can't see. I don't know. I'm super inspired by it and excited by it, as I'm sure people watching are as well. But yeah, I mean, like, I probably never would have thought or asked that question if you hadn't shown or represented, everything that you're doing in this way. Because now that you can see it, it's like, well, now you're asking questions and way more relevant questions to maybe how things can work. And I could totally see, in the sciences and for scientists, I could see them trying to work out theories and concepts in this way, where they are able to visually see how things work and then maybe conceptually think like, you know, what could be really going on or how to solve something. I mean, like, it's just, there's so many possibilities in my mind.
Absolutely, because it's so fast. Like I have a little question, pull up a picture, pop in here. Once you have a sense of what you can do a couple little models, a little thought experiments like this, and like it's either going to answer a question or it's probably going to make three other questions, or at least lead you to the next place you need to start looking. Like I'm so surprised at trying to put ice together. I realized the fastest way I could do it is starting with the dimers, the two water molecule combos. Like it was easier to do it with those pre-linked than individual water molecules.
Right.
So
Wow.
it starts making me think like, is that an important part, or not an important part, or are you more likely to form ice if you've got an environment within your water volume where you've got maybe more dimers, fewer crunched up hexamers or hexagonal.
I know you said that you're not a specialist in water and all of that, but it would not seem the case. It would seem that, but you know, I do have a question though, and this is I think maybe a very basic question. I would love to see maybe the visual representation of that. But as we all know, as you lower the temperature of water, the ice begins to form.
Mm-hmm.
How would that look on a molecular level? How does that change the structure of water from this sort of like, these simple kind of like almost random collections of molecules to forming sort of these more rigid structures? How would that look maybe
Yeah,
temperature wise?
that's kind of what got me to this my little chopstick diagram here, because I was thinking, like, I don't know if this is I'm sure chemists hate everything about this. So yeah, comment down below how terrible of an actual
Gosh, how
representation
could they?
this is.
How could they? But
They're so
yeah,
cute though.
yeah.
But what I was wondering, because most people, when you're talking about water online, they're like, oh yeah, the hydrogen bond just like they're just breaking all the time, and they probably are. Maybe they're breaking in the same way, like that little convection model we showed. But oh, what were we talking about? I lost my point.
Uh, freezing, like
Oh yeah.
yeah.
And that, well, here's another field I'm not an expert on, the difference between heat and temperature. And that is, I think, the direction where that answer is where, if you've got two little molecules, how much they can like, is it just that? Like that is how hot, what am I trying to say? This is the temperature of water. And as it cools down, this other water, there's a limited number of ways that it will happily join with that other water. And as it gets colder and colder and colder, eventually that is the only agreed orientation point, something like that.
So what I think you're saying is, because like these molecules have specific axes in which they can connect to each other, it's almost like when they slow down enough, they can only form in one kind of way.
That's my guess.
Okay.
Yeah, because you've got...
It's so interesting, but it's like, yeah.
So you've got some flex... Because what I'm representing here is this one little, loop. Mm-hmm. Is kind of more like just swarm of negativity. And so, there's a possibility that it can, as maybe that's what temperature is like the movement of those bonds, swirling together. And eventually, as you lose energy, if you lose energy and you're not in the right form, you don't make ice. You are just very cold water in close proximity. But if you get to that critical point and you're in the right orientation, then you've crystallized.
Because there's things that can't freeze, right, and solidify, right? Like there's liquids that don't solidify. Is that right or no? I don't know.
We're gonna need the liquid scientists,
the
specialists in here. But for sure, like that's the next thing I want to do is I'm not ready to build salt yet, but I wanted to form some salt crystals and see like what does that look like when you jam some um, sodium in there. Why is it, does it break up some of the hydrogen bonds? Does it, like, what does that look like in terms of keeping ice from forming or other properties?
Right.
Yeah,
That's
we've got a
so
long list
interesting.
of problems to solve.
I mean, it's fascinating, and it again, like I said before. I mean, our world is made up of so many different molecules and multiple combinations, and they're all interacting with each other, and they're all affecting each other. And so I can see how you have an infinite amount of things to solve because it's literally the fact of of our physical world that there's just so many things going on and interacting with each other.
Yeah. Oh, and one thing I wanted to also kind of point out is I think the fun joining, like we saw the carbon atoms and some molecules and water and how like they can be similar in some ways and how, you know, there's just some, like you said, there's so many different ways that they can go together. There's so many different ways carbon is carbon. There's so many different ways water is water. It really is, there is so much more to, I think, the underlying structure of things.
Right.
And we can represent them better and teach them better. And I think they'll probably teach us some things in the long run. But yeah, I could use some help from the scientists, the designers, anyone that wants to like get involved in just fun, playful science.
Well, everyone listening, you've heard it from Kristen. You know, if you're interested in this at all, do you feel like you can bring some expertise or some focus into this? Feel free to reach out. Is that okay if people reach out to you, Kristen?
Yeah.
Or
yeah, probably Instagram is where I'm at now, or that's
that's
it.
Sure. Why don't we go ahead and hop back into face-to-face chat real quick,
Sure.
and we'll just conclude there.
Okay, great.
So, Kristen, that was really fascinating. Way more fascinating than I even thought it was going to be. And we weren't in there for very long, but I mean, I can very clearly see just how the ideas can multiply as soon as you are trying to build these structures together. I mean, even some of the things that you were talking about, the next things that you want to try and see how things connect and why they connect in the ways they do. I mean, it's intriguing to me, and I'm not even a molecular geologist. Is that what it was? The title, or
structural geology.
Structural geology. You know, I mean, I'm also naturally curious in a lot of things, so maybe that's a factor. But you know, it excites me, and I cannot wait for the rest of our community to actually see this when we put it up. But I'm sure that once we do, and people are obviously watching it right now, and I hope people reach out to you, and I hope that that there's some scientists, I hope that there's some structural geologists watching that want to try this and try and explore some of these things. At the very least, just a way to think through their ideas like you've been doing. I know that you mentioned you've been trying to use this as a tool to convey things to your colleagues as well, and to people that maybe you're presenting to. Yeah, is there any like next steps that you wanted to try in that vein of, you know, after you've maybe explored a concept or you've been able to represent something in Gravity Sketch? Is there anything that you can see yourself doing next as a next step, or something you wish you could do? Anything of that nature?
I think the biggest things are getting a lot of these structural ideas, taking the scientific papers that I've been kind of borrowing their images from, and almost building like an actual virtual lab that people, it's a little more stable environment, but like people can come in, collaborate, build, change, let it grow, and see what people, if you have 100 people design a water molecule, like what would it be? Because the more opinions and the more eyes you get looking at that, you'll get the best result. So
Yeah.
like, could we work through the whole periodic table and like get the best representations of each atom in its different states, when it's, unbound, when it's, you know, there's so many different things to do. But it's getting the people doing the real science into the room with maybe some designers. Like, that's the next thing I want to do, is really get some answers.
Yes. Oh my gosh, I want to see it happen. And maybe I mean, I'm just literally saying this. I just thought of this just now as an idea. I mean, we could maybe try and host something like that at some point. I mean, because our community is full of artists and designers, very talented people in our community, and there's bound to be people in our community that would be fascinated to be a part of something or do something of this nature. So maybe we can.
I can't help but think with all the car designers and how, we were just thinking about convection and how, some of these bonds influence structure, and how, like, I don't know, is there an answer to turbulence somehow down the road, of thinking about, different forms and different, tension versus compression, and like, I'm sure they've got the data, and you guys have the designers and the scientists. Like, that seems like a good place to go to, where you've already got the people, using the software that, a real answer could get figured out, maybe.
For sure. I mean, and that's all goes back to, I think, the whole philosophy that we have at Gravity Sketch, which is we really do want to bring everybody together, designers, non-designers, engineers, scientists, to work through ideas. I mean, that's essentially why Gravity Sketch was created, was to be able to get what's in here, what you're trying to think about in here, and get it out in front of you, so you can visualize it in 3D. The key is 3D, and it's just so essential. And the example of that has been displayed today. So I just want to thank you again, Kristen, for your time and for showing us all of the different things you're working through, giving us a peek a little bit into your world. It's been extremely satisfying and very, very fun for me, as I'm sure it will be for everybody else watching. Is there any final words that you'd like to say, slash where can people go follow you if they want to see more of your work? I know you mentioned Instagram. Is there anywhere else? If not, that's totally cool. Most of our community is very active on Instagram. So, but yeah, any final words like that?
Yeah, Instagram is probably where it'll be. We are fine with slow growth for now.
Awesome.
And I love seeing all the what other people are doing with Gravity Sketch. It's so intimidating what I see, like, some of these real designers doing with I don't know, detailed interior stitching of upholstery. But
yeah, no, it's amazing. And I mean, but I just want to shoot it right back to you and say that, I mean, what I love about being able to talk to our community is seeing new ways that Gravity Sketch is being used. And you are, I think, pioneering in a whole other industry that we haven't really quite touched. And so I'm hoping, as a result of this interview, that we inspire more of those out there like you to explore Gravity Sketch in this way. So thank you very much.
My pleasure. Thank you.
Awesome. Thank you, everybody. See you.